Well, it's been a while since we've all met, and this is a new thing for all of us, so you'll have to be patient. I've got all sorts of little buttons here that I have to figure out how they work. But to be honest, I didn't quite remember where we left off, so I'm going to start with this slide, and it'll be a good review for you if, in fact, we got a little bit farther than this. So what I want to talk about is alterations in either the number or the structure of a chromosome. And the first one is termed aneuploidy, and aneuploidy is the term for one extra or one less chromosome than you should have. So you know we should have 46 chromosomes, and if we had 47, that would be termed trisomy. So it would be 2n, which we know is our diploid number, plus one additional chromosome. Monosomy would be the term for 2n minus 1, so actually 45 chromosomes. The cause of this is non-disjunction, and we'll look at that in just a minute. Polyploidy is a case where there's a whole nother set of chromosomes. So instead of just having 2n, you would have 3n or 4n. This is not compatible with life in humans, so it's not something that we would actually see. Although the example down in the bottom, and if I can figure out how to do. All right, well, we had a little hiccup on the last slide, so you can look at the pictures on the bottom for yourself and see if you can tell what's wrong with each. And remember, that is called a karyotype, when you take a picture of the chromosomes at metaphase and you pair them up. So that was a karyotype. All right, and now we're talking about non-disjunction. This is what happens when you either lose or gain a chromosome in your total chromosome number. So this is a normal, that's the normal way it happens. I shouldn't say that that is normal. But as we look at this, I want you to notice that on the left is normal meiosis. And I think I'm going to try here to put up a laser pointer. And as you can see, meiosis 1 and meiosis 2 give us gametes that each have, in this case, we're looking at a single chromosome, right? One from mom, one from dad, homologous chromosomes. The homologous chromosomes separate during meiosis 1 and go to individual cells, and then in the second phase of meiosis, the sister chromatids separate, and so each gamete gets a single chromosome. When we're talking about non-disjunction, it can happen in meiosis 1 or meiosis 2. And when it happens in meiosis 1, the homologous chromosomes at anaphase don't separate to opposite poles. So they both actually move to the same pole. That gives us one cell that has both of those homologous, that homologous pair, both of those chromosomes. And it gives us another cell without that chromosome. Remember, though, that this is only one chromosome out of 46. So there will be other chromosomes in this cell, but it will be lacking this particular chromosome. And then during the second phase of meiosis 1, the cell does what it's supposed to do, and it separates the sister chromatids. But you end up now with 2 copies of that chromosome in each of your gametes, while the other set has none. When it happens during meiosis 2, so when non-disjunction happens during meiosis 2, what's going to happen is it gets through meiosis 1 just fine. The homologous pairs separate during meiosis 1, but during meiosis 2, when the sister chromatids are supposed to separate, during anaphase 2, they don't separate correctly, and we end up with 2 normal gametes, and then we end up with 2 abnormal gametes. And once again, we'll have 2 copies of that particular chromosome in this cell and no copies of the chromosome in this other cell. Okay, in an example, and probably the most common example for a trisomy situation. Remember, trisomy is that additional chromosome. So there's 4 chromosomes. Is Down syndrome, and it's also termed trisomy 21 because 21 is the chromosome that is affected. So if you look, let me pull up my laser pointer again, And what you're seeing here is a 47. That's telling us the number of total chromosomes. XX is telling whether it's a male or female. In this case, it's a female. And it's also going to say plus 21, and that's the additional chromosome. So it would be in a male 47 XY plus 21, and plus 21 is representing chromosome number 21, where there's 3 copies. That is a result of non-disjunction. It can occur during meiosis 1 or meiosis 2, as you've seen, and the risk increases with moms over 35. We know that we see intellectual and developmental problems, and they can range from mild to moderate. All right, other trisomies that result in alterations in the number of chromosomes are Edwards syndrome and Patau syndrome. Trisomy 18 is an example of a third 18th chromosome. So as you look at this, 47, remember, is our chromosome number, our total chromosome number. XX is whether it's female or male, in this case female, and 18 is the chromosome that we will see as abnormal. So you can see that over here on the right on the karyotype. And trisomy 13 is the case where it's chromosome 47 chromosomes, also a female in this case, and it's got an extra chromosome 13. All right. Other alterations can occur in the number of chromosomes, but when they occur in the sex chromosomes, the X and Y, they are less likely to cause such detrimental problems. That does not mean that they can't cause problems, but for example, an XYY, so somebody having 2 Y chromosomes, is phenotypically a normal male, maybe taller than average, but really doesn't show any significant phenotypical problems. Now, if you think about that, it kind of makes sense, even if you think about the fact that Y chromosomes only carry about 24 genes, right? So there's not a lot of duplication there. And then Klinefelter's is a little bit different than that, and that's where we see 2 X's and a Y. It is a tall male. Usually they are sterile or have infertility problems, and frequently will have some sort of feminized traits, so they'll need to be treated with testosterone to bring on the secondary sex characteristics of a male.